Hello guys, today we are going to solve a GeeksforGeeks problem of a day of 8 June. The problem is stated delete node with data on right. So let's understand with an example. So we have given a linked list and we need to remove its node if there is any element that is greater than on the right side. So let's understand by example. I am currently on the 12, and if there is any element that is on the right side that is greater than 12, so I will remove the 12. If there is any element that is greater than on the right side of the current element, then I will remove the current element. So current value is 12 and there is 15 that is greater than the current element, that is 12. So I will remove 12. So I will remove it. Okay, so I remove it and I will move forward. Now 15, is there any element that is greater than 15 on the right side? There is no element, so I will move forward. Now I will compare, is there any element on the right side that is greater than the 10? So yeah, there is an element that is 11, so I will remove current node. Okay, so I will remove current node. I will remove it and move forward. I will now compare if there is any element that is greater than 11 on the right side. So there is no element. So what I can do, I will move forward. Now I will compare, is there any element on the right side that is greater than the fifth. So yeah, there is an element that is safe, which is greater than our current element. So what I need to do, I need to remove the fifth. So I remove the fifth and will move forward. Now I will look, is there any element that is greater than 6 on the right side? So there is no element. So what I will do, I will move forward. Now I will check, is there any element that is greater than 2 on the right side? So yeah, there is an element 3 that is greater than our current element. So what I will do, I will delete this node and move forward. So the remaining element becomes, let me insert a text box. So yeah, the remaining element becomes 15, then 11, then 6, then 3. This is the remaining element and we need to return the node of new linked list after doing these operations. So let's check this is the output what we need to compare, and this is our output. So it is equal. So our approach is correct. So how can we do it? We can do it. Let understand by one more example. Let's take this one. Okay, or take this one also, but let's understand by a new approach. Let me now understand that we will move from backward and we will update right mass. Current our right mass is int of min. Okay, now we will move from backward and will compare, is this element is less than our right mass. If there is, if the current element that is less than the right maximum element, means there is any element that is greater than the current element, so we need to delete it. Okay, okay. So let's move forward and let's insert okay, and we need to maintain that which node to be deleted at the last. Okay, so what we will do, we will move from the backward, we will compare is the 3 is less than our right mass, so it is not, so we will move to the backward direction, we will move to the backward direction and update the right with 3. Okay, now we will look is the current element is less than our right mass, so yes, this is the current element that is less than, so we need to delete it. So what I mark it that I later need to delete it. Okay, now I will update the right mass where this 3 is greater or 2 is, so 3 is greater, so we will not update it. Okay, and we will move backward direction. Now shift is there, this element is less than our right mass, so no, so what we will do, we will update with the right mass. Okay, so here the value becomes right mass value becomes 6. Okay, yeah, let me write it here. Now we will move backward. Now we will compare if this element is less than our right mass, so yes, this element is less than our right mass, so what will I will mark it. Okay, by 1. Now update it right mass with the maximum value on the right side, so no need to update, we will move backward. If this is the element that is less than our right mass, so no, this is not the element, so I will update it with the maximum value. So what I will do, I will update it by 11 and I will move the arrow to the backward. If this is the element that is less than our right mass, yes, this is the element, so I mark it. Okay, I mark it and no need to update the right mass, I will move backward. Now I will compare if this is the element that is less than our right mass, so no, 15 is never less than 11, so what I will do, I will update our right mass by 15. Okay, yeah, now I will move backward. Is 12 is less than our 15, so yes, 12 is less than our right mass, so I will mark it by 1 and no need to update right mass. So at last I will return for which there is no one, 15, 11, 6 and 3, and I will create a new linked list and I will return the new head. Okay, so let's do it in the code. Here we have given a head, I have created an vector array, that is dynamic array, and I will push all the elements of the node in the array and move to the forward direction of the linked list. At the last I have created a hash array to map which node I need to delete. Currently it is, its element is filled with 0, that shows that we need to not delete the element. Okay, now I will take a variable right mass which contains the variable value int minimum, and the I am traversing for the right of the array and will compare it the current element is less than our right mass. If yes, so we need to delete it. Okay, if no, we can also take it if the current element is no greater than, so what we can update it, right mesh by value of I, and let me comment it. Okay, now I will again reassign the value with null pointer and create a new head with null pointer. Okay, now I'm traversing with the hash array, which will tell that this node is need to delete or not. So for all the element that contains the value 0, I will create a new node and link it to our new linked list. So if hash I value is 0, I am creating a new node and attaching it to our new linked list. If new had our null pointer, then I am assigning a new node to the new node, because new node to the new head. So we will find the new linked list head, and then I am updating the temp with the new head at the last. If this is not the case, so what I am doing, I am attaching, means creating a link between the new node and the temp node. Okay, and then I am traversing, and at the last I am returning the new head. Let's compile and run. Okay, let me connect it with my internet. Yeah, it is connected. Let's compile and run. So it is working fine. Let's submit it. Yeah, our code is correct and all the test case is passed, and I have provided this code here. Just search in the browser skill hub student. This is the site. You will find this site on the top of the, this is not the one. You need to just search skill hub student, and you will find this site on the top of the Google search, and just open it and go into the community section. The application, this platform is deployed on the render. Okay, so it is taking a time so that our server is started. The front end is deployed on the virtual and our backend is deployed on the render. Now, yeah, it is open and I have provided the code here. You can check it out, and it is recommended to first try at your own. Okay, you can find it and check it, and okay, yeah, thank you for watching, and please like and subscribe. It motivates me a lot. Okay.